Welcome back to Science Modernizers. In today's video, we are going to proceed with data analysis, the second part of data analysis. As seen in the previous video, we saw some basic cases on data analysis, and today we are basically going to begin with an example. As seen on the screen, we observe our partners, that is Objective Corporation. Objective Corporation is a national and an international preparation center which trains students to go in for national competitive entrance examinations in Cameroon. Same as Science Modernizers, Objective Corporation is an academic organization made up of teachers, engineers, and medical doctors, etc., who prepare students to go in for national competitive entrance examinations in Cameroon. So, in the center region, that is in Yaoundé, Objective Corporation has four main centers. The first one is found at Carrefour Obilimada Dominion. The other is found at Imana, the other at Mendon Saint Achille, and the last at Hotel du Plateau. So basically, this corporation assist students in getting into professional schools in Cameroon. So for more information, you can get to any of these contacts below. Thanks so much. So let's get started with the video. So to begin with, let's see the problem statement. The question goes as thus. In an experiment to determine the temperature coefficient of resistance for a piece of copper wire, the following results for the variation of resistance with temperature over the temperature range 0 degrees to 100 degrees were recorded by a student. And this table shows the results recorded by the student. We observe that when the temperature is 0 degrees, the copper wire had a resistance of 22.5 ohms. And throughout the temperature ranges from 0 to 100, you clearly see that the resistance of the copper wire increases. That is because for metallic conductors or for ohmic conductors, an increase in temperature leads to an increase in the resistance of the materials, unlike semiconductors, where an increase in temperature leads to a decrease in the resistance of semiconductors. So basically, let's see the problem statement and what we are supposed to do in order to analyze this data. This question was taken from the Cameroon General Certificate of Education Board, June 2015, the question on data analysis. So the resistance is related to the temperature by the equation R theta is equal to R naught into 1 plus alpha theta, where alpha is known as the temperature coefficient of resistance. So the first question says plot a graph from which alpha and R naught could be obtained, 14 marks. The next is use the graph to determine the value of R naught and alpha. And the C part says what is the physical significance of R naught. So let's get a proposed solution to this particular problem. So to begin with, R theta is equal to R naught into 1 plus alpha theta. And in the previous video, we saw that in order for us to plot data on a straight line, we always need to make it resemble the general equation of a straight line, that is y equal to mx plus c. So we can rewrite back this expression in the form y equal to mx plus c by expanding the brackets as shown on the screen. So where r naught times 1 gives r naught, r naught times alpha gives r naught alpha theta, and rearranging we get r theta is equal to r naught alpha theta plus r naught. So we clearly see from here that this is already arranged in the form y equal to mx plus c. And if we compare this equation 1 with the form y equal to mx plus c, we observe that y is equal to r theta, x will be equal to theta, the gradient will be equal to r naught alpha, and r naught will be the intercept. Now notice that this intercept is the point where the straight line cuts the y-axis, and from our table of values we can basically see that already. Since the temperature is 0 degrees and which is plotted on the abscissa axis, it definitely tells us that the y-intercept of the graph will be 22.5, since at 0 we get a point on the y-axis. So it means that line will cut the y-axis at the point 22.5. So definitely from question B, which says determine the value of r naught and alpha, we see that r naught is the y-intercept and the y-intercept is basically given by 22.5. Let's proceed with the video to see the next part. So In this question, we shall be required to plot a graph of R, that's the resistance, at given temperatures against the temperatures. So let's get a plot to see how these points will behave on the graph. So if these points, when these points are plotted, it basically gives you this straight line which you see. And one thing we observe is the properties given about a graph seen in the previous video are basically respected. So the first thing is we have a graph title, and it was stated that when the graph title is written in small letters, we have to underline. So the next is the labeling of the axis, which is very accurate. If you haven't watched the previous video, I will drop the link in the description and you can get access to the video. So basically we see that the first thing we had to do again was to deduce a scale. Now you notice that the scale on the y-axis does not begin at 0. Reason for this little arrow which you see telling us that the scale continues, or the graph continues, telling us that that is not the origin. Whereas on the x-axis we begin at 0. And an appropriate scale which I chose was taking 1 centimeter to represent 2 centimeters to represent 1 unit on the vertical axis, and 1 centimeter to represent 5 units on the horizontal axis. So I began the graph with 22 since my first point is 22.5. So definitely if I begin with 22, then I can get 22.5. And if I keep on skipping 2 boxes, I have 8 values on this table. I have 8 values on this table, so definitely it means I'm going to occupy at least 16 boxes out of 22 boxes, which is already far good in order to plot the graph. Likewise, on the horizontal axis, I had to use 1 centimeter to represent 5 units on the scales of temperature. In other words, 2 centimeters to represent 10 units, and that is the scale which was suitable for this question. So basically, plotting the points, we come to realize that this straight line linking the point is the best straight line, and the properties of the straight line is seen in the previous video, and the link shall be dropped in the description. So this line touches all these points, and so it is the best straight line. There are several lines which can pass through these points, but you have to get the best of amongst all the straight lines. So that is a plot. Now, in order for us to determine the value of alpha and R0, we can already see that R0 is this value, and from the table we can read it to be 22.5. So it occurs only when this value is 0. If the temperature was different from 0, then we could proceed using the other procedure, that is making the intercept the subject of the formula in equation 1 we saw above, and substituting the values of the gradients etc. Now we saw that the relationship between alpha and R0 was very related to the gradient. So we have to calculate the gradient of this graph in order to determine the value of alpha, knowing that the gradient is the change in vertical rise, is the vertical rise divided by the horizontal rise. So if we extrapolate coordinates on this graph, we get that this point is the point 16 on the x-axis, 24, and this other point is the point 72, 24. Likewise, this other point. So we can use these points to calculate the gradient of this graph, knowing that the gradient is the vertical rise divided by the horizontal rise. So since we know that the gradient is equal to alpha R0, then alpha R0 is the gradient of that straight line. R0 is the intercept, and on this graph you observe that the value of R when theta is equal to 0 is 22.5 ohms in bracket the y-intercept. So therefore, as we said earlier, R0 will be 22.5 ohms, but the gradient M is given by the vertical rise divided by the horizontal rise. So we get it as R2 minus R1 divided by theta 2 minus theta 1, which gives us the point R2, that is this point 28.8 minus 24, this other point 28 minus 24 divided by 72 minus 16. So doing numerical application, we get that the gradient is equal to 0.0 0.0857 ohm per degree Celsius. And notice that the gradient is not unitless, since it is the ratio between two physical quantities, that's the resistance and the temperature. So the gradient has units ohm per degree Celsius. Now, since the gradient is equal to alpha R naught, then we can deduce the value of alpha by saying that alpha, by making alpha the subject here, that is alpha will be equal to the gradient divided by R naught. But we know the value of R naught to be 22.5 ohms and the gradient is 0.0857. And we also notice that ohm, that the unit of the gradient is the ohm per degree Celsius and the unit of R naught is the ohm. So the ohms will simplify and we shall be left with the per degree Celsius. So therefore, the value of alpha, which is the temperature coefficient of resistance, will be in per degree Celsius, and numerical application gives us alpha to be 3.81 times 10 to the negative 3 per degrees Celsius. Now going to the last part of the question, which asks us the physical significance of R naught. So R naught is simply the resistance of the wire at 0 degrees Celsius. So this generally brings us to the end of this video, and in the next video we are going to analyze the case of an exponential graph where linearization will be necessary. So thanks very much for watching. Please don't forget to like, share, and subscribe. For more information and any question, you can drop your questions in the comment section and it shall be attended to. So Science Modernizers modernize the educational world.